Thank you very much, Simon, and good morning, everybody. Thank you for the opportunity to speak to you all today. So Simon's shared the title. We're going to be talking about some of our experience in trying to apply some of these approaches and principles in transport systems, and talk about some of the challenges, particularly around data and processing data. Looking forward to your questions later on. Okay, so Immense, so you might not have heard of us. Our focus as a simulation company is on forecasting, so being able to project realistic days in the life of the transport system, and there's lots of use cases for it. There's a lot of other folks working on digital twins focused on the transportation sector. These are some images cropped from Google, but suffice to say, it's a cross-industry challenge around doing this well. But there's a big opportunity if we can get it right. So this is around being able to apply the principles of reusable, consistent digital assets and use them within the transport domain and enable them to forecast predominantly business cases and design decisions, information for business cases and design decisions. And the big target, the big opportunity, being able to make it quicker and easier for people to answer their questions and do so with greater assurance, greater agility. We've been building our capability in collaboration with the UK public sector. So this has been a series of programmes over the last few years with the likes of National Highways, Department for Transport, Oxfordshire County Council, Transport for London and other parties. And one of the key focus points has been able to have approaches that we can reuse with those clients across multiple use cases, so that people get better value from their investments in the digital assets. I'm going to focus this morning on the Oxfordshire build programme, but it's also relevant for many of the others. Okay. So there are two acronyms that you'll hear me use. There is MIMAS, which is the software front end and system that sits together to build models of infrastructure and mobility services. It's a new cloud-based platform built through an innovation procurement partnership in conjunction with a series of UK partners highlighted top right. So bringing together a whole series of new technologies that would not have been brought together without that approach. OMM is the other acronym I'll probably use, which is around the Oxfordshire Mobility Model, which is the specific implementation of this in Oxfordshire. So it's bringing together a lot of these approaches. And we're at quite an exciting stage. We're doing a lot of the final pre-launch testing and validation of the data system. Okay, so a few facts and figures to orientate people. I appreciate this is a sort of a broad community. So we built these models to work within the framework of the Department for Transport's guidance. That enables them to be reused for a lot of different public sector business case purposes. We've taken the general principle, as many do, of backcasting to be able to prove validity. So the base year for these models is all 2019. There's about 1.5 million people.
Robin, you're muted.
We just lost your audio, Robin.
Interesting. Okay. And then we've been forecasting forward for a 2024 year and for a 2035 scenario year. It's a day in the life of the whole system, so 24 hours, and it's covering both all of those event-based activities, but also providing outputs in a structured, time-based way. We've got about 700 different zones of activity, tens of thousands of entities and elements in the supply side of the model, and hundreds of different configuration points where you can get it right or wrong, which all have an effect on how the simulation performs. Okay, so I'm going to step through a few items around what we've built and some of the challenges that we've run into along the way. Okay, forward from there. So building the network, you get data at various different levels of granularity. You have to turn it into something that can be simulated. Lots of cross-checking between different data and mapping sources. Surprisingly high levels of inconsistency in a lot of that. We then have the details of how you go from a link and node model down to the level of lanes and connectors. So all of the turning movements of all of the vehicles are correct and in line with what we do. I didn't give the number of lane connectors stat, but it's another order of magnitude higher than some of the things we're talking about. On the demand side, we're looking at a day in the life of these millions of agent activities. And so we're trying to pull together data from partial observations from mobile network sampling, from on-street counts, but also survey data around how activities are composed. And there's an awful lot of inconsistency and meshing of these different data types. But gives you the opportunity to provide something that will run through and replicate the behavior on street reasonably well. So there's a very quick video here, I'm conscious of the time. So a lot of our focus in this, and I think they're lessons that may be relevant and reapplicable in other parts of the community, are around being able to make these data assets available. So having some level of referential integrity around where the data comes from and how it's processed through all of these many different stages. The accessibility of the end result, so you have to be able to run it and rerun it and rerun it, because you're going to go through a lot of cycles of proving and testing and responding to different queries around how a model performs. And then that brings me on to assurance, which is probably the last point to bring together, is that with these many different stakeholders that all have value to gain from a shared asset, there's a need to meet the formal business case requirements, and they're outlined here, demonstrate that against a whole series of different models and criteria, and then also be able to replicate the types of interventions and scenario tests people want to do. So we can do a whole series of different use cases already with what we have today, and then a whole set more that are much more around operational decision making and what can be done. So in conclusion, there is an enormous opportunity here for being able to reuse digital assets across the transport system stakeholders. There are everything from billion-dollar investment cases through to day-to-day assessments of signal timings and disruptions. And I haven't even mentioned the use cases beyond transport systems. But there are a lot of challenges that still remain in how to process data and reconciling the uncertainties and the discrepancies in those different data sources. Hopefully that's given you an overview of what we've been doing in Oxfordshire. Really happy to take any questions and look forward to engaging with the community more widely around it.